Hello and welcome to the final day of Circular Motion Notes. Today we're going to add in these ideas of friction and angles. And in particular, we're going to talk about three primary examples. As we're going through this, I do recommend that you go to Schoology and download the notes that are posted in today's folder so that you can follow along and add things in. Even though you're just watching a video of me doing the same, it'll still be better for your brains as you're trying to understand this stuff. Because I'm going to tell you right now that this is a little bit more involved than some of the things that we've looked at before as far as circular motion goes. And just like yesterday, the reason that it's more involved isn't because the equations are harder, but because we're just interpreting different scenarios. So we're going to add three primary different scenarios into our repertoire today. First, we're going to talk about rotor type problems. And when I talk about rotor here, I'm referring to that crazy cylinder fair ride that spins around really fast so that people end up getting stuck to the side. There is a lot of physics at play in a ride like that to make sure that people don't end up slipping down the wall and falling down. And we're going to talk about what forces are acting to make that happen. Then we're going to talk about car turns. So when a car turns on a road at a really sharp angle, going at a certain speed, there is a force of friction, that is providing that centripetal force, causing that car to move in a circle. And we can do some calculation based on what we know about friction already. And then the final piece is going to harken back a little bit to what we talked about last unit as well, and that is angled ropes. So in particular, when we're talking about angled ropes here, it's angled ropes when we have something spinning with a fixed point on the top, and then this object is moving in a circle, kind of tracing out this conical path with the rope, but making a circle as you go. So we're going to talk about all three of those different examples as we go through the notes today. And unfortunately, I'm not there for you today or tomorrow, but the good news is you will have access to this video that you can go back and focus on certain examples if you need them repeated as you go through this stuff, both in your notes, on quizzes, and then ultimately on the quest and the test. So before we jump into our stuff for today, a quick announcement, a quick plug in for something that's happening this weekend at the high school. You may have noticed I have posted in Schoology, but something is happening called Spooky Science Saturday this Saturday, and it's running from 8:30 to 12:30, and we need more students to help run this event. Currently we have 150 different elementary school families that are signed up, and what it is throughout the morning we have different science experiments and demos set up around the science rooms. And like I said, we're looking for more students, especially seniors in physics, to help out with this amazing event. All you need to do is fill out this form, and then the primary thing is to talk about your interest and level of availability. So the primary commitments that we're asking of you is that time on Saturday morning. So if you are free, this could be a great thing for you. And then just a little bit of time, either 0 hour on Friday before school or after school on Friday, just to get trained in and make sure that you understand what exhibit you are running, so you know how to kind of walk through the kids. They love this day. It is so cool for them to be at high school, learning high school science from high schoolers. So I highly recommend it. If you do this, we will sign off on 4 hours of community service, if that is something that you are looking for. If that is not a big enough incentive, we also feed you pizza at noon, so come for the free pizza, but make sure that you sign up for this commitment form so that we know you are coming. And if you have any questions, feel free to let me know. I may not be in class, but like this pumpkin guy, I am always ready to help out and answer any questions that you might have. Okay,